All right, so we learned how to export our file out to STL and bring it into a slicing software that allows us to then get that G code, that computer language that talks to the printer, because the printer is basically a robot. It's not going anywhere, but it has sensors and does react to its environment. So, kind of by definition, it's a robot, and it's autonomously squirting plastic, or extruding is the proper word, in the shape and pre-designed patterns that we told it to via the slicing software, via the G code. So, but back to the CAD, the computer aided design, the whole purpose of learning how to do this is to solve your own problems. I want to show you a problem I just solved. Um, so I just moved into a new office, and there's a metal plate outside that you can slide little plastic name plates into that are kind of like laser or something. They're etched, they're engraved out. Maybe there was a machine that did it, and they would order these. Well, Fairmont State no longer has the capability of doing that. I don't know, the company doesn't do it anymore or whatever. I was told, sorry, we can't get those. We're trying to figure out how to handle all these little metal plates that are already mounted on everyone's doors and how to get new things. So I said, well, I'll just make my own, So, uh, as I advised before, you never begin a project without taking careful measurements or knowing what you're going to do. So I started on a piece of paper, and I sketched out the dimensions of the thing. Let me grab it. So I don't work for chemistry, but this was the strip. So I determined using a caliper that it was 2 millimeters thick, and I looked at it and it was engraved inside. So I figured, well, it's about a millimeter of the black plastic and then a millimeter of some other laminate on top. So I happen to have sitting in my office gray and black plastic. I didn't have beige and black, but I figured here's what I'm going to do. I'm going to print some gray, and then I'm going to do a second layer, and I'm going to do it in black, but I'm going to use the extrude feature to remove material 1 millimeter deep. And my theory was that the gray would show through. So, and so if you look over here at my model tree, it's called, you can see that, here's my work planes, top, front, right. And if I scroll down, there's sketch one. So let's open up sketch one because I do want you, if you're working with kids and they make something, they're like, Mom, it's broke. I don't know how to fix it. What's going on? So you have to then dissect what they did and figure out how to fix it. So let's go into sketch one, which is what would have been the original outline. I'm gonna square us up to the face, and here I can see I measured out the plate was, you know, 37 millimeters because we're gonna stick in metric, and we're gonna stick in millimeters for all these projects, okay? Um, and I measured it at 152 across, and so here's the one I made compared to that one. So they're really close. I would say that um, I might be a millimeter shy on one end over here. Maybe it's 153, but otherwise it's really darn close. So and what you could do also, I'm in the sketching tool. I can say it's 153 millimeters. Okay, I just messed something else up, but we'll see how that works. So I'm done with my sketcher. Hit the checkbox, come back out. Okay. Then what I did was I did a second sketch. So you can see, then I extruded sketch one. Let's look at that. I extruded sketch one. Okay, so if we want to see the thickness of it, if we look at it in isometry, you can see now that that's no longer a dimensionless square. It is now essentially a cubic form, right? It has a third dimension. It has a z-axis now here. And I guess I made it 2 millimeters thick. Okay. Actually, it could be a little tighter. It does stay in there, but it could be a little tighter in the slot. So maybe I want to make it a little thicker, 3 millimeters. Okay. Then I did a second sketch. Now this second sketch, what I did was I looked at my tools and oh, there's a texting tool right here. Okay. And so I went ahead and clicked that. I added text, and what we can do is if I click in here, we should be able to edit text. So now I can see that, if I type something wrong or whatever, I can change that. There's also different fonts you can choose. Maybe I want Roboto, not Roboto Slab. Um, Bold. Was it already bold? I can't tell. Nope. So it definitely looks different now. Okay, that's a different font. Further, I wanted to center it in here. And to do that, I took the dimensioning tool, which if you remember, we used this before. That's the arrows pointing like this. This is a very, very important tool because if you want to put a hole in something or an object, or you definitely need to know how far it is, and that's part of this pre-designed understanding of what I'm building and how it's going to get built. So this is where it gets to be math and engineering, right? This is where we're getting the STEM part in it. So we just made this 153 millimeters, and I made it 2 millimeters apart from there. So I'm going to say it's 2.5, and that should center it now, I think. So it looks pretty good. Okay, check. And now what I did to make those letters, which are just now a dimensionless layer, they don't have any depth to them, is I extruded them. So I extruded them 1 millimeter into the material to create that engraved kind of like aspect to it. And I think that looks fine to me. That looks at least as deep. If I think it's deeper than what they had their original one. Then I went through and I said, how is it going to slide in? The metal bracket has a little kind of edges on it. And so I went to the edge of the material and I chose essentially, let me I'll delete that one. So if we look around here at this object, let's see, there it is. This edge is not deleted. Oh, is not chamfered. So I'm going to click on that edge right there. So I've only chosen the edge itself because that's what I want to do something to. Look through my features up here, and I can see, oh, chamfer. And I'm going to make this, I think I just did 1 millimeter for all the rest. Nope, looks like they might have been 2 millimeters. Okay, can you see how the edge just got removed? Okay, I say checkbox, good. And that looks pretty sweet. So anyway, that's how I solved the problem I had. And that's what I'm trying to emphasize is once you get familiar with using CAD, these are things that you can do yourself. So let's start a new project. I'm going to hit OnShape, create document. So you don't need to follow along step by step right now. I'm only going to show you one new feature. Um, and we've already done a cube. We've done a cylinder. Let's do a sphere. Now, a sphere is going to get us into our revolve. And we're going to also learn about the cutting tool, which is also really important. So pick a work plane. Anyone. Lindsay, which work plane should I work on? Top. Okay. I just read her mouth. So I click on the top, see how that works. Now it's highlighted. So okay, I've selected one. I also could go over here to the model tree, click on the word top. I am going to spin it around, so I'm looking straight down at my work surface. I'm going to now go to the sketching tool. This sounding familiar? It was a week ago, but hopefully the pattern I'm doing, you're like, oh yeah, click this, click sketch. Okay, so now the tools have all changed. Now I have the sketching tools, and we're making a sphere. Okay, so to make a sphere, what's the two-dimensional version of a sphere? Crystal, you got a helper there. What do you think? Yeah. if we're looking at what's a sphere versus what's this two-dimensional shape?
Circle.
Yeah. So what we're gonna do, look, I have different circles in here, right? So here's my circle tool. There's a center point circle, a three-point circle, elliptical circle. Let's just choose a center point circle. I'm gonna snap to the origin, see how I get close to that spot and it just highlights. So I click once and I drag my mouse away. Um, if you screw this up, you can always go back and edit the dimensions. But at this point, if I click one more time, it's asking me what dimension I'd like my sphere or my circle to be. Okay. And we've been making everything 1 inch just because 1 inch was kind of a convenient number. And here's a pop quiz for you because conversion of metric to imperial is important. So, what would a 1 inch diameter circle be in millimeters?
It was 22 point something. No.
Krista with math.
25.41.
25.4. Yeah, so it turns out 2.54 centimeters or an inch. And because, metric is just a 10 base system, you just move the decimal, right? So it's 25.4 millimeters is a 1 inch. Check. Okay, so I did that. Now, um, in order to do a sphere, I don't want an entire circle actually. What I want is I want half of a circle and an axis that I can spin around. So how am I going to do that? Oh, I got the line tool. Okay, line. If I bring my line tool over, it should snap. See how again, it's highlighting and snapping. So I'm going to click right there and it's snapping to the main lines. And I bring it down here and I can see it, the circle highlighting again, the outline of the circle. So I click again and now it wants to make more lines. This is really annoying because you're going to end up with like 18 lines all over the place. And you're like, let go, stop making lines. So just the escape button is your friend. I'm out now. Now, I don't know if you can see it, but there's a line right there. Okay. And so what we're going to do is we're going to look up here our tools, and we don't want a full circle and a line in the middle. You just want half a circle. So there's the trimming tool, and I'm going to trim that off. Okay. So now I have half a circle with a line through it right here. And the dimension tool should still be referencing this diameter here. Okay. We're going to say check, we're done. And now what we're going to do is we're going to highlight this shape. Actually, this is a great time to point out that I saw this mistake coming up and I was just going to see what happened. The lines are dotted. Do you see they're not a solid line? So that indicates it's called a construction line. Often I will make a construction line through something so I can find the midpoint or mark where I want to be able to snap to or make a measurement. I don't want to make that the object. I just want to have that as a tool for me to specify, well, here's the halfway mark or here's this. So I have to go back in the sketcher and click on that line. And I didn't notice this when I was doing it, but the construction line is on, meaning that this is not a real line, it's an invisible line. I'm going to turn that off. So that's a solid line. I'll click that line and turn that off. So now the shape shaded in. So I guess I should be embarrassed. This is not a smooth video where I show you perfectly how everything works. But I guess in a cool way, you get to see a mistake, right? So the worst part is I knew it was going to happen. I saw the dotted lines. I'm like, why is that a construction tool? So apparently that button was either I bumped it by accident or it was selected. So the shape now shaded in and filled in. That tells you that the shape is complete and closed. Why is that important? So for example, if I were using the line tool and I did a line, a line, a line, and I got really, really close, but I didn't close that. You see how it's not shaded in? Okay, that's not a full shape. So if I were to try to choose that, essentially the computer wouldn't know how to handle it. CAD software would be like, I don't it's going to spill out into everywhere. Even though zoomed out, it looks like it's one line. It's not. So if I click on that and I were to drag it up and I can connect it. Let's see, it's not connecting. That should be connected now. Oh, that's not shading in. So if I were to take a square and do like this, see how it shades in? That means it's a closed object and all the edges are closed. Okay, so I'm gonna just highlight these things and get rid of them. Okay, so we have a closed shape. It's shaded in. We can move on. So now we're gonna try a new feature. So now that I'm out of Sketcher, we've already done extrude. We haven't done this other one here called revolve. So I click on the revolve and it asks me for two critical things. One, it says right here in the blue, faces and sketch regions to revolve. So the face is the shaded object. Click. It says, okay, great, got it. Okay, then what's in red right down here, now it's asking me for, can you guys read that? The revolve axis. What axis am I revolving around? So now I'm going to go down here and click on that line right. Let's see, click on the red box and click on that line right there. So what we're saying is we're going to take this two-dimensional half circle and we're going to spin around and that axis and add material as we go. I can show you that um, because it says full right now. Let's see here. I can usually preview. Oh, that's just the shading. I was hoping I could show you how I could do it not fully around. Let's see. Oh, here we go. One direction. So it says now I've done it 30 degrees. Can you guys see that it's now only a slice of fancy cheese? Okay. And there's an arrow here. So I can, here. So this is what I wanted to show you. This is what's happening when I'm revolving around the axis. You can see the axis right here, which is the edge of that half circle, and it's adding material as we go. So if you only wanted to make a turtle shell, there's actually one of the cool stories I read recently was people saving turtles that who had their shell damaged by a propeller if they 3D printed a shell for them. But so, if I only needed a turtle, I'd go around, only halfway. If for some reason I wanted to have Mrs. Pac-Man, I could do that. But usually, and it depends on what you're making, um, we're going to go all the way around. So there is the profile, there is the axis, and there's the shape. So check, I made a sphere. I'm going to reiterate that next step, which is how do we make this ready for 3D printing? So I go down here to the word part. The whole object I made is highlighted. I right click and I choose export. It says great. You probably want to export out in an STL format. I'm going to call it sphere and it's in millimeters. And we talked about resolution briefly before. If I'm doing a cube, I could choose coarse. It's just 90-degree angles. It's like really easy, and there's no need for any rounded objects. But if I drilled a hole through that, or if I had a round object, now I really do have to choose the fine resolution. It's going to add more triangles, which is what STL files are. It says download. I hit export. It says great. I'm going to go ahead and do that. It's saved right here. Okay, so what I'd like to do, we're going to pause and you're going to make a sphere. So, all right, so we made a sphere. And I don't know if you had a chance to go ahead and click on the part, export it out as STL, but that was the last part. Let's reinforce this concept of revolve. It is a really cool feature. I'll create a new document. Now, when I was in middle school, I made a lamp on a lathe. So we took all this wood, we glued it together, and I had this big giant chunk of wood, and then we put it on that lathe, and it spun around, and I chiseled away wood, right? So if I want to make something like, I don't know, a lamp, what I'm going to do is I'm going to create a half a profile of what I want, and then I can revolve it. So if you want to mute Crystal, that would be
Oh, yes, I'm sorry. I
okay.
apologize. Thank you.
So I'm going to click on the front work plane, and in this situation, I'm going to click my sketching tool. I'm just going to use my line tool. Now, in this case, I'm going to make a larger object. Okay, so this is going to be a small desk lamp. Okay, but still, it's going to be, say 5 inches across. So I need to be 2.5 inches in half of the profile. Okay, so 2.5 inches in metric is going to be, let's see, I'm in convert mode already, is 25.4 times 2.5 inches equals 63 and a half. So, okay. So I'm going to go ahead and make a line. And I draw it out and I click and I'm going to say 63.5. This is not really an important measurement. I made this up. But in trying to model, saying I know my exact dimension of what I want because that's important to me. I click that. Okay. And then it's going to go up. So this is the base of my lamp. It's going to go up, say, 1 inch. So click, I'll say 25.4. And then it's going to like come in to here. And now I'm just making a shape. Let's see here. I'm all zoomed. We want to go ahead and zoom to fit here. And we can keep making more of these little lines. So it's just kind of a whatever shape I want for my lamp. And let me square that back up. And we're going to go ahead and create a line that goes from here to here. I'm not going to ask you guys to all do this. I just want to illustrate how this works. And as this is important though, see how I am moving this line around and see how it's saying, oh, oh, ooh, if I snap to that point, I now have a shape. You see how it all shaded in? I don't know why I didn't do that earlier when I showed you that little other example, but that shaded in means it is now an actual closed shape. Okay. And if I'm not quite sure how tall this is right now. Let's use a dimension tool. That's this tool right here. I'll click on that line, drag it out. It's 133 millimeters. And maybe I need to make it, I'm not sure it's gonna be, let me do this one. So I made it 150. That's what I needed to do for my lamp. Okay. I'm gonna click check. And so then I go into our revolve. It says, give me the face that you want to revolve. I say that. And it says, give me the axis. So I click on the word axis right there. And I say, this is the axis. And it says, there is your, actually, this looks more like a chess piece to me, actually now. Okay, but the point is, okay, well, I say, yes, that's great. Green checkbox. I made a pawn, apparently. Okay. Let me do this one more time again. Okay, on shape, create, document. Okay, nose cone. So I've explained to you earlier that one of my favorite things to do is build rockets. And we just did a whole rocketry summer camp and stuff. And one of the things that all the students did was they all made a nose cone. So to make a nose cone for their rocket, they chose a work plane. Okay, then they knew certain dimensions of the rocket. So for example, they knew that it was, let's make a small one. We have a 1 inch diameter body tube. And so we want half of that. So half of a 1 inch tube is what in millimeters?
Would be 12.7.
Correct. So I'm gonna choose my line tool. I'm gonna go here. I'm gonna just line tool, click. I'm snapping to that axis right there. I'm gonna say 12.7. Good. Now the shoulder is the part that sticks into the rocket, and I'm gonna make that a half an inch, which is gonna be another 12.7. Okay. Now we're gonna stick out 1 millimeter here. It's a teeny bit. Okay, now I'm going to escape because at this point, what's important is that we want to be able to make the nose cone a certain height. So the height of this nose cone um, is going to be 75 millimeters. So I'll type 75. And here's a fun thing. I'm gonna escape from this, is that I'm gonna use a new drawing tool we haven't used before. This is called a tangent arc. And there's different flavors of it. Okay, there's a conical, elliptical, center point. I like the 3 point. So I need to choose 2 points, which are the ends of my curve, and then I kind of define the radius of it. So to do that, I'm going to zoom in really tight and find the edge of that little 1 inch millimeter. So I got that. Then I'm going to click on the top of my line here, and now I can define my third one. And so this gives me a really neat shape for a nose cone. So this could be a very strange nose cone. Okay, it would get kind of larger as it went out, which would be kind of fun, but I'm gonna choose, this looks like a pretty standard nose cone to me. And you see how it's shaded in? So that means that this is a fully enclosed object. So I hit check. And again, we're just reinforcing the revolve feature. Like Todd, I don't, how would I use revolve and why? Well, apparently for making a pawn for your chess piece, that was missing. You can 3D print and solve a problem you have. Or in this case, a nose cone for a rocket. So I'm going to go ahead now, hit revolve. I choose, it says face of sketch. Okay, that's the face. It says, and I click on the word axis. What's axis? This is the axis I want. Boom. Okay, that's what I was thinking. That's what I was imagining, a nose cone for my rocket. So I click check. Now the problem is this one's rocks, it's solid. The whole thing's full. That would make a very heavy nose cone, which might be okay for me, but I also don't really want a fully filled in nose cone. But I'm gonna click on this bottom circle right here, and here's a new feature. Okay, we have all these different features up here. Okay, so these are like ones that create three-dimensional objects. These are ones that you can tweak your three-dimensional object. And one of them says shell solid. Click on that, and it says, I think I want to do a 2.5 millimeter thick wall. I'm going to say, nah, you know what? I think 2 is enough. So it's going to hollow out the entire object 2 millimeters. Check. And so now I have a hollow nose cone for my rocket. So again, this is how I use Revolve on a routine basis. Pretty cool, huh? All right. So I think we have 7 minutes left. Are we cutting this off at 1 o'clock? How are we doing?
1 o'clock would be good for me.
Okay. So what I'd like you to do is go ahead and uh, practice exporting your feature, your shape, your whole part out as STL. So we click on it here. All right, it says part. We right click, choose export. It says, okay, what do you want to call it? Part Studio One, Part One. Now I'm gonna call it 1 inch nose cone. STL format, millimeters, resolution fine, export. Okay, so that's something that I'm going to have you guys do. And just to reiterate, how do we get this into the software wherein we print it and we do that slicing and stuff? So we talked about this last class. Just to re-emphasize how this works, what we're going to do is we're going to use a slicing software. So I have the Makerbot print software, which I sent you in an email so you can download. And in Makerbot print, I'm gonna have to change my share. Okay, so hopefully you're seeing Megabyte print now. Yes, no, maybe not. Okay, let me try again.
It showed up for a second.
How about now?
Yes.
Can you hear me now? Okay, great. So over here in the project panel, I'll click that. I'll click Add New Model, and here's 1 inch nose cone. And I'll hit Open. And it says, great. I think I should print it in this orientation. We talked briefly last class about this matters. Okay. So if I were to print this on its side or upside down, it's going to have to print all kinds of support plastic because it can't. I mean, again, imagine that you're building something with your cake decorating tool, right? So you're squirting frosting out or, kind of like thick caulk or your hot glue gun. And I want you to, print out in the middle of the midair. You can't do that. You'd have to have something to print onto. Now, if I was printing a nose cone on its side, it'd be hard to get that curved shape without building a support system underneath of it. And so if I print it in this orientation, then it's going to be able to just print circles and build up and get smaller and smaller as it goes. And so that is the correct orientation for me. Okay. And from this part, what we would do is we would export out our our nose cone, and it's going to create that G code. And as I mentioned last class, Makerbot is the printer that we loan out from the ERC. And it works very similar to other 3D printers. I do like here it tells you PLA, material, how long it's going to take. It's going to take this long, but it doesn't give me as much cool data as I can get. Here's a print preview. Actually, it's showing you printing it. So that's model material, prints a little support ring around there, and prints it out. So that's kind of showing you the orientation of how it's going to print. And that's the path that the 3D printer nozzle will make as it moves around. Kind of cool, huh? So that's how the Makerbot print software works. On our third class, we'll be getting together in person. We will go ahead and actually open the Makerbot printer and we will turn it on and we will level the bed and we will print a test file. Then we'll import files that you made, your STL files, using the G code. So you don't just take an STL file. There's that one more step, right? We have to tell the printer where to position itself, how much plastic to squirt, and then what path it's going to take. And that's the language that this little robot uses to know how to build your part. So I definitely had a misconception when I first started that I could just stick an STL file into the printer and it would print it. But I was neglecting to understand that there's a whole processing of the image itself, of the file, to create the step-by-step code that's used in the G code. Okay, at that point, do you have any questions? So we learned a new feature today called Revolve. We've hopefully reinforced exporting out as STL, and we've glimpsed again that next step where we import it into a slicing software, in this case, Makerbot.
I have one question. I think it's pretty simple, but whenever I go to make that circle, if I don't get the type, like if I don't do it right to type in on the first try, I cannot figure out how to bring up a box for me to type in again. Does that
Great.
make sense?
No, it totally does. And so I'll go ahead and leave this on the recording. I'll show you how to solve that problem because
Sure.
it is my expectation that you're going to run into these issues, right? That's kind of the reason that we're doing the training is that, I mean, if you just want to watch me do it once perfectly, that's great, but it doesn't help you solve real life issues. So
Sure.
we were talking about the sphere, correct?
Hmm.
Okay, so we're in the sphere, and here's sketch one. I'm gonna open that
I'm
up.
not seeing your screen right now. I don't know if
Oh,
you're
that's right.
intending.
Sorry, I
That's okay. No
was
worries.
looking at MakerBot.
Yep, that's fine.
Uh,
There you
okay,
go.
so here we are. We're back where you were. Now you said I didn't have a dimension. Oops, I have no dimension. I deleted it. Okay, so how do I define the diameter of the circle? So what I'm going to do is I'm going to click dimensioning tool. Okay, click on that line, and that's how I can define. Now this is kind of a weird way to define. I defined the length of that line. Okay, what I can do also, let's delete that again. Dimension tool. Click on the circle, and this is going to give me now. It's going to be the radius, right? Because it's not a full circle, so it's showing me the radii. But we knew the radii of half of 25.4 is 12.7. So that's how I can define it. Okay. But
Thank you. That's helpful.
yeah, even if I were to go ahead and let's see, to get out of the dimensioning tool, delete everything. Okay. And I were to start over with the circle and I clicked on it, it has a dimension. So um, let's see. And now you can't see it, but there is a dimension there. It does have a size. And so what I could do, so here's a circle with no obvious indication of the dimension, even though there is a dimension to it. And click on my dimensioning tool, click on the circle, and it should be giving me the full diameter now.
Mm-hmm.
Okay, so that dimensioning tool is your friend. And
Okay.
so now I can do 25.4, and now I've made my circle.
Mm-hmm.
I've defined it.
That's great.
And when you got that warning about your sketch is not fully constrained or defined,
Mm-hmm.
part of that is that some measurements are defined, some aren't, and and very likely you have two measurements that are in conflict. So you may have you might even get a warning over constrained, meaning that you've added so many measurements on there like, well, you said it was this radius and you said it was this diameter, but those aren't the same. So I'm
Mm-hmm.
I'm I'm confused. Um,
Sure.
and so you can always just click on a dimension and you can delete it, or you can, again, here's to add a dimension. That's giving me the radius right there. I can always then, change it. Now it's a 2-inch diameter circle. My revolve's angry at me because it doesn't know what it was looking for. So I'll just do those. Face. Oh, I don't have half a circle here, but so I can't do a revolve without half a circle. I forgot the bisecting line. Click, click, and we will delete half of that.
I put a hat on.
Yeah, your hat looked very cool.
And now the revolve says, give me the face, check.
It's
Give me the axis, check.
the pet packets in there.
That's how I did that.
Yeah, that's cool. Mm-hmm. Makes sense.
Great. All right. Well, I have us down. I'm going to go ahead and stop the pausing, recording.